All right, lorries. So here's our lorry, brilliantly drawn. Give a reason the roof is curved. Okay, so you've got a curvature to the roof here. 1 mark. Well, that is simply to reduce drag or air resistance. Okay, so to reduce drag. You could also write to reduce air resistance. Okay, either is acceptable. Right, so this lorry goes up a long slope or hill, okay, which is 145 meters long and 17 meters high. Okay. State the relationship between work done, force, and distance moved in the direction of the force. 1 mark. Okay. So to write it out, you would say that work done is equal to the force times distance moved in the direction of the force. Okay. So work done is force times distance moved in direction of the force. Or you can write, so I would recommend, because that's the full and correct definition in this case, to write that out as a sentence. Okay, show that you know, show the examiner that you know that it's force times distance moved in the direction of the force. Okay, and then you can just write work done is force times distance. Okay, but yeah, take the opportunity to show the examiner you know what you're talking about and include in the direction of the force. Okay, all that for 1 mark. Right. So we're told that this lorry weighs 180 kilonewtons. All right. Calculate the work done against gravity in moving to the top of the hill. Okay, so the lorry starts off here. Okay, and it drives up to here. Right. Don't be fooled by this number here, okay? That's a red herring. You don't need it. It doesn't matter how far the lorry is traveling horizontally, okay? The work done against gravity in moving to the top of the hill only depends on how high the lorry has moved, the vertical height through which it's moved, not how far it's gone horizontally. So you don't need that, okay? Gravity operates downwards, so work done against gravity only concerns vertical direction, okay? And it's moved through a distance, a height of 17 meters, okay? So, work done is force times distance. So, going to use that. Work done against gravity is the force. Now we're told that the lorry weighs 180 kilonewtons. So that means from the centre of gravity of the lorry, because of gravity, it's being pulled downwards by a force of 180 kilonewtons. Okay? So that's the force, 180 kilonewtons. We'll convert into newtons now, okay? Times the distance, and it moves through a distance of 17 meters. Times 17, okay? And that's it. That's the work done against gravity. And stick it in your calculator, and that turns out to be 306,000. Okay. So work done, energy unit is joules. Okay, so joules. We're not going to leave it like that. There's a number of ways we can express this. We could say You could say 3.06 megajoules million. Okay, so I would write that. You could also say that it's 3.06 times 10 to the 6 joules, but we don't write after the decimal point in standard form. You only have to have one digit, so I'll put that in brackets. You would actually write 3.1 times 10 to the 6 joules. Okay, so I think that's probably the best answer to get. Again, hedge your bets, write them all down. The examiner is forced to give you the marks if he sees it on the page. Okay, so write the lot down. And that's how I would leave it in the exam. Good. Okay. Right, 3 marks in the bag. Next, the lorry takes 8 seconds to travel up the hill. Calculate the power of the lorry. 3 marks. Okay, it's an easy 3 marks. So, well, it's only easy if you know what power is. And you should know this, okay? Power is the rate at which energy is converted, okay? In equation form, you would write that power is energy divided by time. Rate means per second, divide by time, energy per second, okay? So, it's pretty straightforward. We know the energy, okay? Use the precise value in your calculations. Don't use that value. That's been rounded, okay? That's not quite accurate. I know it's the correct way to present the answer, but for further calculations, you don't want an error carried forward. You want to use the exact value of energy. So you put that in your calculator, okay? So the energy is 306,000 divided by time is 8 seconds. Stick it in your calculator and you get 382,500. Okay? Right, power. What is the unit of power? You've just got to know this. It's the watt. Okay? Or the joule per second, but they want you to give the unit, and if you have to give one or the other, then use watt. Okay? Show them that you know that it's watts as well as joules per second. Because you could work out that it's joules per second, because energy is joules and time is seconds, right? But you have to show the examiner that you also know that that's known as a watt. Okay, now again, we've got to tidy this up. Would you leave it like that? Probably not. How should we write this? 3.8 times 10 to the 1, 2, 3, 4, 5 watts. Yeah, you could do that, get that on the page as well. You could also write 3 I don't know, 380 kilowatts. Get that on the page. Just get everything on the page, okay? Then you're guaranteed to get to satisfy the examiner. Okay, so you'd write that to 380. That'd be to 2 significant figures. Okay. Right. Anything else you can do with that? Probably, but I think that's enough. Yeah, it's fine. Let's move on. Okay. Right. Okay, we're looking at this now. So we've got a velocity time graph of this lorry. Okay, it accelerates for 6 seconds and then it moves at constant velocity for 2 seconds. Right. State the relationship between acceleration, change in velocity and time. 1 mark. Okay, well, you've just got to know this. Acceleration is change in velocity. In other words, delta. We use delta for change. Change in velocity divided by time. Okay? It's the rate of change of velocity. Again, power is rate of energy, if you like. Acceleration is rate of velocity change. So divide by time. Okay. Calculate the acceleration of the lorry during the first 6 seconds. Right. Now, if you look at your question sheet carefully, you will see that it's 14.8, yes. So I haven't drawn this brilliantly accurately, but it looks, if you sloppy and just look quickly, it looks like 15, but it's actually 14.8. So that's the velocity that it finishes at and moves at constant velocity for 2 seconds of 14.8 meters per second. Okay? And it starts doing that at 6 seconds. All right, so what do we have to do again? Calculate the acceleration of the lorry during the first 6 seconds. Right, so we've got the equation. They made sure we'd written that down already. So that's a hint. So acceleration, change in velocity. Well, it finishes at 14.8. And what did it start at? 6. So the difference you subtract. That's the delta V. Okay, so 14.8 minus 6 is delta V. And the time, it changes that velocity in a time of 6 seconds. Okay, so that becomes 14.8 minus 6 is 8.8 divided by 6. Stick it in your calculator and you get 1.46666, which is 1.5. That's 6, pushes the 4 up to a 5. Acceleration, meters per second squared, to 1 decimal place. Okay, easy. Good. Right. Calculate the distance travelled during the 8 seconds on the graph. 3 marks. Right. You have to know that on a velocity time graph, okay, the area underneath the graph is the distance travelled. Okay? If you didn't know that, learn that now and remember it forever. You've got to know that. And don't mix up like distance time graph with the velocity time graph. That only works on a velocity time graph, okay? The area under the graph, it has to be velocity time. So where should we write that? Here. On VT graph, area is distance travelled. Okay? You've got to know that. So that's what we're going to use. So I change of colour. So we have to work out this area. So it stops at 8 seconds there, the bit it's asking about, okay? I mean, if the lorry stops dead like that, you'd be crashing into a wall and stopping instantly or something. Anyway, look. It doesn't matter what the lorry does from that point, whether it accelerates or crashes or drives off a cliff. We're only interested in in the first 8 seconds, okay? Because it says during the first 8 seconds. All right, look. So, divide it up sensibly. How do we work out this area? Well, look, we've already got one nice block there. That's a sensible point to choose. So, we'll use that. How do we divide this up? Well, clearly, that is the best way to divide it up, okay? Because that's easy to work out. It's a rectangle, so's that, and that's a triangle, and triangle is just half base times height. So, area is that plus that plus that. What's this area? Well, that's 2 seconds times height of 14.8. So that's 2 times 14.8. This is 6 wide times 6 high, so that's just 6 times 6. This is half base times height, so half times base is 6 times the height is from 6 to 14.8, which is 8.8. Okay, so the distance is half times 6 times 8.8 plus 6 times 6 plus 2 times 14.8, which is, turns out to be 92 meters exactly. Boom. Okay, so remember, on a velocity time graph, distance is area. Right, and then it's easy. That was an easy 3 marks. Right, the lorry has 6 tyres. State the relationship between pressure, force and area for 1 mark. Okay. Well, you've just got to know this. Pressure is force divided by area. Okay? Force per unit area. Right. The pressure in each tyre is 240 kilopascals. Right. The weight of the lorry is 180 kilonewtons. Right. Calculate the area of each tyre in contact with the road. And we're told it has 6 wheels or 6 tyres. Okay. Right. So, you have a wheel in, so here's the wheel, okay, in contact with the road. Here's the road, okay, and the weight of the lorry is pushing down, and there'll be some rectangular area here at the bottom of the tyre which is actually in contact with the road. So looking at it from above, the part of the tyre that's in contact with the road, it'll be this sort of rectangular area like that, okay? And the pressure inside the tyre is 240 kilopascals inside one tyre. So imagine you're inside the tyre, there's a pressure of 240 kilopascals pushing down on that area there, okay? And whatever pressure is pushing down on the inside of the tyre, that is the same pressure that the road will be experiencing. Because that little section of tyre is not moving, it's not going, the forces are balanced. Look, you can get bogged down thinking about this too much, okay? In an exam situation, don't worry about it too much, okay? The point is there are 6 tyres, so you've actually got 6 of these areas, right? So the 2 tyres at the back, 1 at the front on both sides, right? Okay, 6 tyres. So just stick it in the equation, right? The pressure is force over area, so let's just stick it in. So we're told that 240 kilo pascals, convert to the correct unit, has to be in pascals. Pressure is force. The weight down is 180, convert to the correct unit, has to be newtons. Newtons divided by the area. Now, I'm going to write AT. That means total area, okay? So that's for all 6 added up, okay? Because it's the same pressure in each tyre, and the total area, there's 6 tyres. So just don't mix up total area with area of 1 tyre. Okay, so rearrange, bring 80 up here, bring that down there, and we get, therefore, total area is 180,000 over 240,000. 3 zeros there, 3 zeros there, another 0 there, another 0 there. So that's 18 over 24. 6 goes into that 3 times, 6 goes into that 4 times, 3/4, that's 0.75, okay? Meters squared. For the total area, all 6. So you would just say, therefore, the area of one tyre is A total divided by 6. So 0.75 divided by 6 is 0.125 meters squared. Okay? Would you leave it like that? Too many decimal places. Let's just say 0.13 meters squared to 2dp. Okay, and that's it. Okay, quite a long question, but not too bad, right? You've just got to know your equations. You've got to know that power is energy divided by time. You've got to know that acceleration is change in velocity divided by time. You've got to know that on a velocity time graph, the area is distance. You've got to know that pressure is force over area. But if you know all that, and come on, that's not that much to learn. Work done is force times distance. If you know all that, then in the direction of the force, then the question is pretty straightforward. So, learn all these things. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drjem.com, and I'm also on social media. Thank you.